Hi everyone, I am Hassan Mohamed from period 2 in physics class. Today I will talk about fake physics. Okay, so let's enter. So this contents I will talk about I will cover it today. Okay, so let's start with Man of Steel. So let's listen to video.
Are you listening, Clark? I asked if you could tell me who first settled Kansas. Are you all right, Clark?
Okay, so fake report. So this scene where Clark Kent starts to release that he has a powers, and one of those powers is X-ray vision. He could pass through people's bodies to see their bones and organs just with his eyes. What's real physics? This related to Unit 4 with nature of light. How does Superman have X-ray vision? I think the first question is how does vision work? We see things because light reflects off them and enters our eyes, or maybe it's a light source itself. It but the light has to enter your eyes to see things. X-ray are just another type of light. X-ray is electromagnetic radiation of extremely short wavelengths and high frequency with wavelengths ranging from about 10 power minus 8 to 10 power minus 12 meters and the corresponding frequencies from about 10 power 16 to 10 power 20 hertz. X-ray are a form of ionizing radiation. When interacting with matter, they are energetic enough to cause the natural atoms to eject electrons. What's real physics? X-ray can cause harmful biochemical changes in genes, chromosomes, and other cell components. When passing through living tissue, the biological effects of ionizing radiation are complex and highly dependent on the length and the intensity of uh, exposure. X-ray radiation survives take advantages of these effects to combat the growth of malignant tumors. So the X-ray vision of Clark, if uh, if X-ray are coming out of his eye, he can't see inside people. But there are X-ray around and the bag radiation. It's not very much, and that are pass through people's bodies, and he could see them. It's just shooting out X-ray from his eyes, but it could hurt people. Okay, so second content is Deadpool. Let's listen to his video.
X gon' give it to you. What? Wait for you to get it on your own. X gon' deliver to you. Go get some.
You gonna do superhero landing? Wait for it! Woo! Superhero landing! Yeah, that's really hard on your knees. Totally impractical. They all do it.
Okay, so what's the fake physics? In this scene, he talks about the superhero landing. We can see the superhero landing with one knee, one fist, and one foot on the ground. So three contact points, but it's a very sudden move. It's not like a normal landing. This is related to Unit 3 gravitational. Is this the way a normal person would hit the ground? And of course, the answer is no. You have to think about the forces acting on a person while he is landing from falling from somewhere. Um, F is a force of Newton, and m is a mass of body, and g is a gravity, and and the pressure on the knees equal F over A. F is a force, and force weight of the body is a surface r m power 2. The key is to have the forces as possible on the knees. One way to do that is to increase the distance over which you stop. So if I jump and land on the ground, I let my knees bend, and my center mass moves down while my knees bend, increase the distance over which I stop and decreasing the force. A thing called a parachute landing fall, and you don't even stand up. You head bend down, roll over on the ground, and increase the distance over which you stop even more. That's the best way to do it. The superhero landing, it's just going to be bad idea. You know that's really hard to your knees and impractical. So Captain America, let's listen to his video. So what's fake physics? As we see in the scene, buggy flicking off with a helicopter Airbus AS-350 and the Captain America rushing in to stop it in the time from taking off, pulling it by his arm. This is related to Unit 2 energy and momentum. Have to ask ourselves, is this physically possible? This scene is against the impulse of momentum theorem. Momentum is equal to the mass of an object multiplied by its velocity and its equivalent to the force required to bring the object to a stop in a unit length of time. So uh, P is a momentum, and m is a mass, and v is velocity. The mass of this plane is 1240 kilogram plus mass of the passenger 100 kilogram. Its average speed is 250 kilometer per hour. Total mass equal 1240 plus 100 equal 1340 kilogram. Momentum equal 1340 by multiply by uh, 69 equal 92 and 460. Thus, it would require a more significant amount of force to bring the plane to stop equals 92 460 kilogram. So the force applied by his arm is not enough. The plane should not stop also. Time machine. So what's fake physics? In this scene, scientist Alexander sits in his invention, the time machine traveling to the future. The fake here is that the machine is not moving, it is still in the same place. What's real physics? This is related to Unit 5 modern physics. Most physicists do not believe that traveling back to the past is possible in practice. Especially relatively theory provides us with a mean of time travel into the future when it predicts that that time runs more slowly. As we approach the speed of light, so we get to the to the future before anyone else. Einstein, Einstein's general theory of relativity in 1915 shows another way of slowing the time down. A gravitational field will do the same job as traveling at the speed of light. The effect can even be seen due to the Earth's gravity, but the effect is tiny due to the relatively small mass of our planet. Time measurements depend on the motion of the experimental relative to the events. Proper time is a time interval between two events measured in a reference frame where the events occur at the same position, and the time interval between the same two events in a frame moving with relative velocity. So this is a rule of this time. So Spider-Man 2. Let's listen to his video.
What do you got for me today, New York?
Okay, so what's fake physics? This is related to Unit 1 dynamics. In this scene, Spider-Man shows a free fall when he jumps off a high building for about 3 seconds for a distance of about 100 meters. So his velocity equal distance over time. His velocity should be 33.3 millisecond. As he swings between buildings, he travels in a circular motion that gives him a more incredible speed, leading to a more significant impact force on his shoulders. So in real physics, when a body moves in a circle at a constant speed, it is constantly accelerating because its direction is constantly changing. The acceleration is a change in a direction resulting from a force directed towards the circle's centers. Spider-Man has an average weight of 75 kilograms. He's moving along a circle of radius. Assuming to be the distance he fell with speed experiences a centripetal force that has a magnitude given by Fc equal mv by power 2 over r, and is directed toward the center of the circle. So Fc equal 75 multiplied by 33.2.3 power 2 over 100. The force acting on his arm is 831.66 Newton, which is a significant load pulling on his arm. So Spider-Man would experience a bone fracture due to his fall and swinging. So that's all, and thanks for listening.